Hello and welcome to the section 6.2 lecture. Today we're going to be looking at solving one-step equations with rational coefficients. So keep in mind what all that means. First of all, the one-step equation thing is relatively new. It's definitely new to us this year. I know that we've done it, we just haven't formalized it. And then the rational coefficients, rational coefficients just meaning that we're going to have decimals and fractions involved. Okay, so one-step equations. You've written and solved one-step equations involving whole numbers. Now we're going to learn how to do that with equations containing negative numbers as well as decimals and fractions. Okay, so the big thing with solving one-step equations is that we want to use our inverse operations. So we want to undo whatever's happening to the variable. And you'll hear me say that quite a bit. What's happening to the variable and how do I undo that? Like in this one over here, I don't think it's a problem that we actually have. So just using that as sort of a guiding example. What's happening to my variable? My variable's right here. I should be able to point that out pretty quick. And then what's happening to it? It's being multiplied, even though it doesn't say multiplication there. That's what happens when we write numbers right next to variables. It's being multiplied by negative 1.5. So how do I undo multiplying? Okay, well, I would do its opposite, which is divide. So I'd want to divide by negative 1.5 on both sides. And again, both sides of the equal sign. That's the important thing. Granted, we're going to be working with one-step equations today, so it won't throw anybody off too much, I would hope, on where to divide this mysterious negative 1.5 in that problem. Let's look at the problems that they have for us. First one is they have x plus 3.2 equals negative 8.5. Totally valid equation. Everything works. And we just want to know what's the variable going to be. Now, we could definitely guess, right? We could take a guess at what it's going to be. But more importantly, we want to think about how am I going to do this when these problems get more difficult, or even the numbers get more difficult that I just can't think of, oh, what's that number have to be? And I think that this is a great example of that because my knowledge of taking a number and adding something to it to get a negative number is not that great. I can't just think of that off the top of my head. Okay. So this is a great example of why this process is important. So we want to undo, what's happening to x. X is being added by 3.2. 3.2 is being added to x. So how do I undo that? I subtract 3.2, and I do that to both sides of the equal sign. The second one, and this is a great problem. I do like this because it still looks like an addition problem, and it is. It's just an addition problem with a negative number. So like another way that you could write this where I could say, well, it's kind of a subtraction problem too, is I could rewrite this just as easily as y minus 2/3 equals 8. That's the same problem as this one that they give me. They just go through the steps of, all right, well, let's turn that into y plus a negative 2/3 equals 8. And then let's commute. Let's flip those around. Negative 2/3 plus y equals 8. And that's the problem that they have. So with that 2/3 being negative, or if you want to think of it this way, this is probably a little more straightforward. But I like this one too. It's a good example. With that 2/3 being negative, and even though y is adding, okay, it's adding a negative, we want to add to both sides because we want to undo just that negative 2/3. We want to undo that. But if it would help you to rewrite that equation in a way that made it a little more straightforward, feel free to do that. Okay, you can do all that preliminary work just as easily as I did. Now, I can see where it's going to end a little bit quicker than you can, but you'll get there with more practice. The next one, 30 equals negative 0.5 times a. Well, I have a being multiplied by a negative 0.5, so I'll do the opposite of that, which is divide, and we get negative 60. Cool. Last one, Yeah, that's a weird question. That's a weird way to write that. Negative q over 3.5. You can think of that how you will. I know that I know that I have division happening here, and I should multiply to undo that division, which is great. That's wonderful. Now, with that negative being out in front, I don't typically think of that negative being part of the denominator. In fact, I never use it as part of the denominator. But this one's a little bit tricky, because if all I do is multiply by 3.5 on both sides, I would have negative q equals something. Okay, I don't want to know what negative q is. I would want to know what positive q is. So they throw that negative into that 3.5 and multiply by that. Okay, let's look at doing this for ourselves. So I like space. I like to take up space when I'm doing problems. I like to write things out so it makes sense to me. So 4.9, a positive 4.9, if you want to think about that, you can. It's a positive 4.9, is being added to z. So I want to remove that. I want to undo that. So I'm going to subtract it from both sides. Okay, over here they cancel out. I get a z equals negative 9 minus 4.9. That may be tough to think about. If you have to use a calculator, feel free. But we should get negative 13.9. And this is probably my favorite part of math in general, is solving equations, because we get to an answer. We get to an answer, and not only do we get to an answer that should work, we could always plug it back in for z and see if I get negative 9. When I go 4.9 plus negative 13.9, I should get negative 9. The next one, I have r minus 17.1 equals negative 4.8. What's happening to r? It's being subtracted by 17.1. So the opposite of subtraction is addition, and we have 17.1 that we're going to add to both sides. Okay. Sometimes that's easier said than done. Negative 4.8 plus 17.1, that's going to look like positive. Might be easier to look at it this way, 17.1 minus 4.8. Most people would agree that that's easier, because then you can vertically do it. We got 0.3, 12.3. And it is a positive because the 17 is bigger. So 12.3. And you should have on all of your answers the variable equals 12.3, or variable equals whatever it equals. The last one we have here, I've got negative 3c equals positive 36. What's happening to c? It's being multiplied by negative 3, so I'm going to divide by negative 3 to undo that. And that's going to give me a negative 12. And there we go. Awesome. What do they have in store for us? Sometimes it might not be enough just to know how to solve them. We might have to write them first and then solve them. And I love that this section's all about solving equations with irrational numbers, and they focus more on the negative part. It says that negative numbers often appear in real-world situations. For example, elevations below sea level are represented by negative numbers, and when you increase your elevation, you're moving in a positive direction. When you decrease, you're moving in a negative direction. Okay, so this example says that a scuba diver is exploring an elevation of negative 12.2 meters. As the diver rises to the surface, she plans to stop and rest briefly at a reef that has an elevation of negative 4.55 meters. You want to find the vertical distance that the diver will travel. Okay. There's multiple ways to do this, but I guess writing an equation and solving it is one way to do it. If we want to figure out how far, and I'm going to use this picture to kind of figure that out. If we want to figure out this how far she traveled, one way to do that is to take the the starting location and add the distance that she travels, and that's going to equal our ending position. Okay, so this equation will work. I think that there's better ways to do it, but in an effort to come up with a problem that we can set up, this will work just as well. Okay, so we know that negative 12.2 plus x is going to give us our negative 4.55. Or in other words, our starting location plus the distance we travel equals the ending location. Seems to make sense. So we solve that by adding 12.2 to both sides, and we get 7.65. Okay, traveling a vertical distance of 7.65. Explain how you know whether the diver is making a positive or negative direction before you solve the equation. Moving in the positive or negative direction. How do we know that? Well, we know that because the ending location is a smaller negative or is higher than the starting location. So ending location is higher than the starting, than the starting. So that means that she has to travel upwards. Okay. It says here that an airplane descends 1.5 miles to an elevation of 5.25 miles, and we want to find sort of its starting elevation. Okay. So if it descends, I don't like that they don't give us just blank space. Come on. It starts at some location and it descends, so it goes downwards 1.5 miles, and it ends up at 5.25 miles. Okay, this seems to make a little bit of sense here. Starts at a location, goes down a distance, ends at a location. How do I undo subtraction? That would be addition of the same number. And we want to add 1.5 to both sides. So we get, working backwards, I guess, 570, let's say that the right way, ends at 6.75 miles. Okay, so 6.75 miles. There we go. Okay, sometimes we do want to write and solve one-step multiplication and division problems. So those other ones were addition and subtraction problems. These ones are going to be multiplication and division problems. And here it looks like we're going to use some temperature. Between the hours of 10 p.m. and 6 a.m., the temperature decreases at an average of 3/4 of a degree per hour. So it's going down. Let me kind of make a note of that. It's going down 3/4 of a degree per hour. How many minutes will it take for the temperature to decrease by 5 degrees? Okay, so they're mixing hours and minutes with us here. That's okay. We want to write an equation. We're going to say down 3/4 of a degree per hour is negative 3/4 x, where x is the number of hours, equals negative 5. So we want to see how many hours, how many iterations of this negative 3/4 is it going to be until we get to negative 5. So it's kind of a two-part problem. First thing we do is we solve for x by doing the opposite. Now there's some hidden things in here. When I want to undo multiplying by a fraction, that's actually dividing by a fraction, which we don't do. We keep change and flip to divide by fractions. So really what would happen here is that we'd have negative 3/4, and we would want to divide that by negative 3/4. But in order to do that, we keep change and flip to negative 4/3. Okay. And so you can just think about that when you're dealing with fractions. You can just go to that. Instead of think about dividing it, we just want to multiply by the reciprocal. Okay. So then we get 20 over 3, 20 thirds. Okay, 20 thirds of an hour. That's somewhere around, sorry, now my brain's not working, 6.6 hours. Okay. Yeah, that's 6.6 hours. But that doesn't work too good when we're talking about minutes. So we do keep it in the 20 thirds idea, 20 over 3. And then we have to convert hours to minutes. Well, since there's 60 minutes in 1 hour, we multiply by 60 over 1, and it takes us to 400. So it's going to take 400 minutes for the temperature to decrease 5 degrees. All right, let's see if we can set these up and solve them. The first one says the value of a share of a stock decreases in value at a rate of $1.20 per hour during the first 3.5 hours of trading. Write and solve an equation to find the decrease in the value of the share of stock during that time. Okay. So it goes down $1.20 per hour for 3.5 hours. I don't see that as an equation. We want to find the decrease in value. Okay. Yeah, I see that as just a multiplication problem. I don't think I see it as, hold on, for the first 3.5 hours of trading. So, yeah, let's just write it and solve it, I guess. I don't think it's going to be equation-based the way I'm going to write it. It goes down $1.20 per hour, so it's negative 1.2 every hour in 1 hour. And maybe we write that a little bit differently. Negative $1.20 per hour for every hour. And we want to multiply that by 3.5 hours. 3.5 over 1, technically. Yeah, this is how I'm going to do this problem because this is how I would. They probably want us to write it as an equation where we've got like, gosh, I can't even think. Sorry. It's been a while. So yeah, we're just multiplying here. We're multiplying straight across on top and bottom. And it looks like we just have 1.2 times 3.5. So 1.2 times 3.5, that's 0, 1, 6, 6, 3. And so we've got $4.20. And it is negative. So it goes down $4.20. Yep. Okay, next one. After a power failure, the temperature in a freezer increases at an average rate of 2.5 degrees Fahrenheit per hour. The total increase was 7.5 degrees. Write and solve an equation. So this one I do see as an equation because it goes down, or it goes up 2.5 degrees for every hour. And the total increase was 7.5 degrees. So how many hours was the power out, right? So what's happening to this? It's being multiplied by 2.5. So we want to divide by 2.5 on both sides. And so to me, it seems like that's going to be that it was out for 3 hours. Okay, it was 3 hours that the power was out. Just double check. Yeah, that is the last thing. I think for a code word today, it only makes sense that we go with sort of an adjoined code word. A hyphenated code word. We're going to go one step. because that's what we really discussed today, were one-step equations. Okay? Have a good day. If you have any questions, make sure you let me know. Otherwise, we will see you in class.